At AV&R, our mission is to humanize robotics. We decided to create this podcast series to help you demystify the world of robotics and discover what some of the brightest minds in the field are doing. Welcome to Robotics for All Podcasts by AV&R.
Audrey Boucher-Genesse is the academic coordinator for the Robotics Engineering program at the University of Sherbrooke. Audrey and the engineering faculty have developed a robotics engineering bachelor's program while innovating how their courses are being delivered, focusing on project-based learning. In this conversation, we are joined by David Mailhot, our robotic finishing development leader, and together with Audrey, we have a behind-the-scenes look into their unique approach teaching robotics and raising the next generation of roboticists. The result is a group of students with a portfolio of innovative projects and unique skills. Audrey walked us through a few very impressive examples as we hear what it's like to study robotics in 2021. Hope everyone enjoys the show. Here we go.
Good morning, David. Good morning, Audrey. Thank you for joining me.
Morning, Mike.
How are you guys?
Good.
Yeah, I'm doing good as well. It's a nice
Excellent.
day. Summer's up, so.
I know, and I got to ask, Montreal or Toronto? I think I know the answer, but I'm going to ask anyways.
Not following hockey. Is that a good answer?
Not at all? Okay.
I'd be tempted to go as Audrey, but I'm gonna go big. Montreal in 7, and we're gonna have Cofield scoring in overtime.
Ooh,
that's the way I see it. It's probably gonna go on Joe Thornton beard, and it's gonna go right in the net. That's something I'm.
Well, like a good Toronto fan, I'm nervous to make predictions because I've been wrong so many years. So I'm not going to say anything, but I'm excited to watch the series. And I'm also excited to talk to the both of you. The University of Sherbrooke, this is a pretty new program, the Robotics Engineering program. So I'm really excited to jump into it. I've got a 15-year-old daughter that is trying to figure out, what track she wants to go on. I don't know if she'll follow in Dad's footsteps and go into robotics. It looks like some form of science, but we're looking at the different programs and stuff like that. So really excited to have you here, Audrey, and you contributing, David, to this and hearing about what the University of Sherbrooke has been building. So maybe to start things off, Audrey, it'd be great. You've been a key person in building the program. Maybe you could give us a little bit of history, and not that there's a whole lot of history, but just, what's been keeping you busy and what you're looking forward to.
Yeah, well, actually, we started the program 4 years ago. To be honest, it would have been like I've been studying in electrical engineering, but it would have been the program I would have chosen if it were available when I started studying. So we started 4 years ago, and it was originally the director of the program, François Michaud, who had the idea of a program really specifically in robotics where students that were doing competitions like First Robotics, Zone 01 and stuff like that, they were doing robotics with Legos and stuff in primary school or in high school, and then they didn't make like the link with, oh, this is mechanical engineering or this is software engineering or electrical engineering. So robotics engineering was really like, oh, I know what this is. Like, I've been doing this in primary school, so I know, like, I can picture myself doing this. So it was his idea, really, and I think it was just a nice coincidence where I called him, like, in 2013, asking, hey, what are your projects? Eventually, we would like to come back to Sherbrooke, because at the time I was working at AV&R in Montreal. And among the projects were, well, I want to build a program. So we just, I think I was just like the person that was like, okay, I'll be dedicated to this project so we can, have a little boost of work going on this project. And it's been really great. Like the robotics engineering program really is a mix of mechanical, electrical, and software engineering, combined with integration of all these components. And this, I think, really answers to one of the needs in the industry. Like, I've been doing electrical engineering, but then when you get in the marketplace, like, you have to learn about other engineering stuff that you haven't learned back in your program. like mechanical engineering. I was not really trained for this. So I remember having, discussions with people, mechanical engineers, asking questions about materials and stuff like, what do you want your gripper material to be? It's like, well, I don't know, what are the choices and what's the difference? And I have specifically no idea. So I think the program really went to answer this kind of need that the industry had as well.
Yeah, when I studied, it was there was no robotics engineering either, and I think I probably would have chosen myself. I was always, when I first applied, I applied for computer science, and then I decided, no, I want to go back to engineer. I want to get into electrical engineering. So I went back to high school, upgraded some courses, and then went into electrical. And now I find in my career, it's a little bit of everything, just like you said. And I think the one challenging aspect, it's a good challenge for students, that it's a great opportunity to learn a bit about everything and develop skills that that allow you to touch you got to be well-rounded in order to do a really good job at in the robotics field. Dave, you're still involved in the University of Sherbrooke. You did your master's program, so maybe just give us a little rundown of what your involvement still in the program, and what drives you.
Yeah. Well, first I gotta say I'm involved, but just a bit, and because I saw from really far away, but I saw what Audrey did, and it's a huge work she did to get this program going on, and it's a really nice program. And just to be clear, I've done my bachelor degree at Sherbrooke, and then my master's at ETS in Montreal. But so I'm involved in giving one class. It's a introduction to simulation for robotic applications. And I've been doing this since the beginning of the program, I guess. Yes, I was there the first year. The first year we built that specific class, Audrey and I still go back each year, once a year to Sherbrooke to give this class. It's really nice to stay in contact with youth and see like participate in like seeing people developing themselves and growing. So it's a really fun, and it also keeps you in contact with project opportunities that you can have with university groups, university people. So important, and you stay. I mean, it's all a way of keeping contacts and trying to reach out to more people. So that's really nice. And one thing you've touched it a bit, Mike. I mean, I don't know if I would have chosen robotic. I haven't questioned myself on this, but probably I would have really hesitated in between electrical, because I really love all electrical stuff, all what's related to electrical engineering. So that's the program I obviously did. But it was clear to me when I finished that robotic. When I finished my bachelor degree, robotic was what I wanted to do afterwards. So that's where I did my master degree. So yeah, no, it was a fun time. And one thing we haven't talked about for this program, and it's there are a few programs that Sherbrooke built that way, but it's the project
learning.
I'm sorry.
Project-based learning.
Exactly, project-based learning. I was looking for the English terminology for that, but yeah. And that's really something worth talking about, because not only you get people that are flexible and able to work in different fields, or at least have knowledge of different different concepts for electrical, software, and mechanical. But you get people that are used to solve problems week after week, because that's the way the program is built. It's some sort of agile or scrum way of giving classes or delivering a program. And it's, to me, that's something that seduced me at the time when I got in electrical engineering at Sherbrooke. That's probably one of the things that got me to Sherbrooke. And that's something that was those concepts were used to build the robotic program, and it's really something that's really meaningful in the way you learn. Yeah.
Yeah, it's a great topic to dive into. Audrey, maybe just take a step back and just for those of us that maybe aren't familiar with the concept of project-based learning, maybe describe it for us at a base level, and then how does, if I'm a new student, University of Sherbrooke, into the engineering, robotics engineering, I jump into Frosh Week, I'm getting excited. So when do I start into this project-based learning too?
From day one.
Yeah.
And that's a challenge, to be honest. Project-based learning, it's really about, the goal is kind of like to have the student who's responsible for his own learning. So he's really like at the center of his process. So we have like I'd say that the teacher is more like a coach. So he's there, but he's not in front of the class teaching, preaching, saying this is how it works, and writing on the blackboard, well, the whiteboard. So it's really like we have like 2 weeks, like mini projects for 2 weeks. So each class, let's say we want the students to learn about electronics and math. Well, they will have grades for the math class, and they will have a grade for the electronic class. But basically, we kind of pick up a bit of both classes, and then we just do a small problem saying, in the next 2 weeks, you have to solve this problem. So this problem is, you have a little electronic board. There's a problem with it. You have to understand what is the problem with it. You have to understand the concepts, like what is a capacitor, and what is, everything that's on the little board. You will have to do the equations, math equations and everything. You have to solve the problem. And at the end of a week and a half, it has to work. Like the really electronic board has to work. So you have to kind of debug it and maybe add some parts or whatever. And you have to solve it and show us how you have solved it. So this is the goal. And so we have like, the small periods with the teacher saying, okay, this is what we'll be doing. The teacher sits down with only like 25% of the people at the time, like 12 people, saying this is the goal of what we'll be doing. So the students can really interact in a small group. And then afterwards, back with the whole class saying, okay, we'll have to solve some equations. Like if we had that kind of problem, but on a smaller scale, how would you do this? And it's the student that comes to the board trying to solve it. And his peers try to help out, saying, oh, I think it would be this way. Maybe I would solve it this way. I'm not sure. And then the teacher can still interact and correct the students, or let them make their own mistakes so they can understand, oh, this is a common mistake. And so like at the end of 2 weeks, you have an exam only on the things you've been doing. And even though you have, normally, and since we were real little kids, we have like many classes in parallel in a week. But in the project-based learning, it's really like we focus on 1 or 2 classes for those 2 weeks. So in those 2 weeks that you're doing electronics and math, you're not doing programming, you're not doing, I don't know, anything mechanical or whatever. You're really focusing on this. And then you do an exam. And then after, like you switch to another context totally. So the next 2 weeks can be programming.
And the cool thing about it is that not only you see the concepts, but typically you get an application, typically, because at first when you get your small 2-week project, and when it gets presented to you the first Monday, typically you go like, I don't understand anything, or, you don't have a lot to rely to. And that's the first meeting you get with your teacher, which is more like a coach, like Audrey says, and you try to identify on what concepts you already know, like what concepts you already know. And then you end up saying, oh, well, you know what? I know a couple of things, more than I thought. And then you read, you get your reading, you read and you understand the concepts, and then you do it. and typically on a 2-week basis, yes, you're focused on something and you don't touch some other thing, but you do it, and by doing it, you learn so much more than only sitting in a class, listening to someone, as Audrey said, sometimes, preaching that his class is the best class because, right? And then, and you're at the center of the thing, and you're doing it. It's really it really focuses on autonomy and on self-learning. I wouldn't say it's for everyone. Some people will perform more or less than other in that type of environment, but it's really stimulating because you end up doing the things and having something that works, and then you start over again, and you end up being really good at this little routine that on a 2-week basis you need to deliver, and you're always confronted to new stuff that you didn't know before, and it's always the same thing. You need to try to find what you can, put your feet on that is solid, and then how you can build on that. That's something you learn to do and you get good at doing, and that's not only technical skills. You develop other type of skills. You develop skills of learning how to learn. You're learning how to build your knowledge base. So that's a really cool thing about this type of program.
Yeah, the parallel. So when we get out into the working world, one of the intangible skills that is so important, especially in the technical field, is troubleshooting. That's what we call it here. So when you're building a robotic system, things will go wrong, because you've got a lot of layers that go into that, and being able to break down what's happening, figure out pinpoint where the problem is, finding that needle in the haystack, that's really a hard skill to teach somebody, and it's a hard skill to interview for too. So for the students coming out and going into the workforce, knowing that the program is centered around that, that's a really interesting advantage for when companies are looking for a good skilled workforce that are able to react to those situations. And it's not just technical. I mean, in the pandemic here, in business too, we have to troubleshoot, right? Things don't always go as well as planned. So you've got to be able to say, okay, what's wrong? This isn't the way the book says it should go. How do we deal with this?
Yeah, and I think it's something as well, like it's fascinating how many concepts you can grasp in like a short time when you focus on this. And I think what you just said, like the industry loved, like when the project-based learning program started, it was 20 years ago. Yeah. The feedback from the industry was overwhelming because the people from the companies were saying, about their interns, like, what did you guys do? Like they're not afraid of the unknown, and they just know, like they dive head first, and it's like, in a problem, it's like they're like, this is gonna be a project, and then they're like really like autonomous. Well, I would say for day one, but still, really quickly they're just not afraid to dive in. So I think it was and there's something else we didn't mention. This is like the project-based learning approach. So this is like, let's say 2 weeks little blitz. There's also something which lasts all throughout the term, which is a bigger project, a team-based project of, like, let's say we put the students in teams of, I don't know, 6 to 8, and they have to integrate really like all the skills they've been working on. So a bit of programming, a bit of mechanical, let's say like, I don't know, like drawing something in SolidWorks, or 3D printing and everything, a bit of electronics, a bit of math, a bit of everything, and then they program a small robot. So that they have the integration of everything, not only, the little circuit, because when like you said, when you build something like a robot, it doesn't always work as planned. So when it's when you put the pieces together that you realize what's working, what's not working. So this is also something key from the project-based learning approach.
So you said the program's been running 4 years. So your first group of students, they're on the edge of graduating?
Yep, in December.
So that group of students, how many projects through the 4 years? I guess that's what, 8 semesters. How many projects about would have they been exposed to?
Well, actually, they have one per term.
One per term,
But
okay.
from the 6th term, they're doing like a bigger project, which is like the capstone project that lasts for like a year and a half. And
Okay.
so for this is like really their big project, but they can build like, you know, a robot from scratch, really. This is the biggest one. So I would say, you know, well, we have like the 5th term, which is a bit special, but let's say 5 projects for the first term, and then one bigger project for the last 3 terms.
Okay. And to set the frame a little bit, we will go into, we have 3 examples of some really cool projects that we'll be able to go through. We're not going to jump into it yet. Now, is this also a co-op? Is there a stagiaire program as part of this?
They have 5 internships that they have to make in, you know, really various fields. So it can be robotics, and to be honest, the people in robotics engineering, sometimes they do an internship. It could be at AV&R, it could be something like industrial robotics, or somewhere where they actually build robots, mobile robots or whatever. But it can also be like an internship in, you know, a student that says, I want to learn a bit more about programming. He can make an intern in, you know, software engineering, or typically mechanical engineering, or, you know, to really focus on one skill that he wants to develop. So they really can do various internships.
I remember when I was there, and you know, Sherbrooke has always been strong on the co-op program. It was true when I was there too, and the word was your interns. They're an opportunity for you to learn what you want to do. You want to do in the future. So try different things, right?
Yep.
And that's the idea. And I think with that kind of program, so the student, they can go in such a wide type of a intern. So that's really nice for the students and for the industry as well, because well, I've always believed in interns. I think it's as for the industry, as for the students, I think it's a great way to kind of bridge, you know, the school and the universities and the industry, and make sure you get this. Make sure that you get to know who's the next generation that's gonna
Yep.
come up here, and you need to be ready on a technical point of view. I mean, technology evolves, that's for sure, but even like people mentality changes, and you need to be ready. So that's a good thing as well to be exposed to interns.
Oh, absolutely. Brings fresh energy into the organization. And you know, I'm the same as you, David. I studied University of Windsor, and that's how I chose my which school I was going to go for engineering was because they had a good co-op program. And for, you know, if any students are listening, I recommend that opportunity. And the work term that really I still think about it, that was a life experience for me. I got a chance to work in Germany for 4 months, and it was at a university, but it wasn't. I did my capstone project during that, but the more important thing was getting to see a different culture, getting over there. I remember putting my backpack on and walking on to the airport and turning back and waving to my dad. And that was before, I think we had MapQuest, but we definitely didn't have Google Translate. And this is how naive I was. I got on that plane not having a German English dictionary. And as I sat down on the plane, I go, wait a second, maybe I should have a way to translate. So the first thing I did when I got over there, I started looking for a dictionary. I went to the bookstore, but it was all backwards because it's German first, English second. So the alphabetical order was the German word. So that's just the beginning of my adventure. And it was like, it was a growing up experience, and taking off the naive blinders a bit. So definitely co-op programs I highly recommend them. Not only industry to engage with students, but students, that's your way to get your feet wet.
Yeah, and actually, you will get to know what you like and what you don't. So it's like, as David said, it's an opportunity, and it doesn't look bad. Like you're going to be there for 4 months. So try other things. At the end of the 4 months, your internship is over. So if you're, I would say, like your study, like you have studies are over and then you get into the workplace. If you switch places every 4 months, it might look a bit weird, but during an internship, it's the recipe for everyone. So it doesn't look
it's recommended.
Right? Yeah,
right?
it's recommended.
Yeah. Now you talked a little bit about industrial robotics and what are the opportunities out there. I think, one of the reasons that we started this podcast is just the robotics landscape has changed so much. And we were poking around, talking to people, and it's such a diverse area now. When I first graduated, industrial robots was the big one. And then that's, I think, really grew the adoption. But there's so many other fields. There's mobile robots you talked about. There's a lot of hospital settings now for sterilization. What are some of the different industries that you're engaging with and that you see that are up and coming?
Good question, because we want to expose the students to what is already in the industry, but also what's coming up. And I would say the students that are probably more exposed to what's coming up is probably the students that make interns in research areas. And so they'll be working with drones or with mobile robots that are being used for various things. Something we see that is being more used nowadays, or that you have more internships possibilities and everything, is the medical field. So robots used in the surgery and stuff like that. Or I'm saying surgery, but it can be an arm that is attached to a wheelchair and that is going to be used, so like we have here in Quebec with Kinova. We have, I think, well, especially in Quebec, what we've seen in the past few years is a lot more of industries, companies that started here and that are really more into making robots or making parts of robots, like robotique with the grippers and stuff like that, instead of just robot users. We tend, like, if you go back, I don't know, 20 years, we were more like we're buying robots and integrating them with something else. Now we're seeing a bit more of people building parts of robots or building robots. And I think probably with all the research that is going on with all the universities in Quebec as well in that field, and the entrepreneurship. So it's kind of there's like various programs that will maybe get the students to get to the next step with some ideas that are part of the research, that maybe will have, I think, a bit more companies that will emerge from this in the past few years.
Yeah, because one of the elements that you guys have is a bit of an incubator program, or is that right, to help students with startups?
It's not part of the robotics program, but it's part of the university. And we have also classes that introduce the students to those concepts. So like how you have like one class, which is, I don't know how to translate it, but let's say a creation of innovative products. And so they really get their hands dirty, saying, okay, so what is the need, like for any kind of application, what is the need of the user? And then I'll start from this and I'll try to create something. And how would this be working if I want to create a company based on this, and how to create value for the customer and everything like that. So we kind of, it's just to expose the students to that kind of reality.
Yeah, you're absolutely right. There's some great companies here. Mechademica is another one. We have Louis Xavier, to shout out to him. He's there now.
Actually, Mike, Louis Xavier is one. I'm giving the class with him.
Okay.
And we're still giving the class together. So yeah, we stay in contact. It's a small world.
Yeah, absolutely. And we did a webinar 2 weeks ago, and the president of the MAQ spoke, and she described, the bit of the Quebec landscape in manufacturing in Canada. And, one of their messages is they're trying to promote the investment in technologies into manufacturing. And we've got so many great technology companies here locally that I think the ground is fertile to really do something interesting and really make Canada and Quebec a very competitive landscape. So all the right elements are there now. I think we're still looking for that tipping point where the fire is lit and we really see a big growth in manufacturing and in the innovation going into it. But certainly I do see a lot of positive signs for that. And this, the pandemic, again, it's lit a fire under everybody's butt to get going on it, including ours.
Right.
Yeah. Okay, great. So we talked a little bit about everything, the project-based learning. Okay, as we're getting to the end of the 4-year, the first group of students going out, when's the graduation?
Actually, their last term is in December. So they really
December.
finish
Okay.
December. Yep.
So we'll
ready
have to
for
check.
task force in January, unless quite a few of them will stay for a master's degree afterwards.
Yeah.
We have like 7 of them out of the 37 first students that are already starting their masters this summer, because they can do that instead. Like they can swap their last internship for kind of small first term of masters. And I know some others also want to continue. So a few of them I think will stay for a master's degree to pursue something in robotics. But then others will be ready for the task force.
That's a good point. So you guys also continue, you have a master's program in robotics to support.
Not in robotics. It's well, not yet. I'm not sure about the future plan, but they can specialize kind of like in, either mechanical engineering or electrical engineering. And to be honest, there were already people that were doing, robotics in their master's degree, but it was either tagged electrical or mechanical engineering. But they were still working on a robot for their masters.
There are a couple of cool groups at Sherbrooke University of robotic, expertise. Either mobile robot with, I guess François Michaud is still heading this this group, but you get a couple of other like domotique, like any house automation stuff. I consider this as really some sort of robotics somehow. So there are already a couple of groups, and it's probably just labeled some other ways, but really you're going to be doing robotics anyway. So yeah, there are a lot more, a lot other groups at different universities, Quebec area, or all around. So yeah, there are cool opportunities there.
Yeah. And I'm still looking for a ROS-based user group. So if you guys ever come across one, tip me off to that. And Audrey, I guess we'll have to circle back in January together to see what type of jobs the students are getting. So we'll put that on the next podcast. We'll schedule one for January, and maybe we can cover a few of your students.
All right.
Okay, let's jump into some of these projects. So what I'm going to do, I'll share my screen. We'll try and be as descriptive as possible. Definitely, this will be in the show notes. If we find that we're not super descriptive, we're going to post this podcast on YouTube too, so that everybody can see.
Can I just make a little context for this one?
Oh, absolutely.
I think both you have like 3 videos. They're all part of the 4th term project. So this is really like the half of their program in robotics engineering, and this project is really like open. So they have to make a robot. It has to have something like articulate, so it cannot be a mobile robot, because we have other projects in other terms that are mobile. So this time we try to be more more like an arm or something that but not something that moves with wheels. And they have to they're really using the agile approach. So like they have I think 5 different releases during their term, and they have to, so they start small and then they improve their robot throughout the term. And so
this project it's the one that runs for a year and a half?
No, it's one term, so it's 4 months.
It's one term, 4 months.
Yeah, and
okay.
and I think the projects for this is for the projects for this winter. They're quite impressive, to be honest. When you think about there are only like 6, 7 students, and they've been working on it, part-time for 4 months.
Yeah.
I think with all the prototyping tools we have now, they can make some stuff really quickly. So it's quite impressive.
Okay, so the first one that we've got queued up is called Quadris. And I'm glad that you made the distinction of mobile robot being wheeled. They weren't allowed to use wheeled robots because this one's mobile and it's really cool. I'm gonna mute this and I'll jump to where we start to see the robot. So for those of you that are not able to see this, Quadris is a what would you call this? A quadrupedic robot? Is that the correct term?
Probably.
Probably. Okay. Maybe the easiest way to explain it, I'm assuming everyone knows Boston Dynamics. They just released a robot called Spot. It's like a dog robot. So this group of students built a very similar robot to that. They call it Quadris. And the video walks us through some of the big elements of the project. So like you were saying, Audrey, we've got mechanical engineering, we've got electrical engineering, we've got, it looks like your facilities. So did they 3D print all of these? What type of facilities do you guys have that they have?
We have a building right beside the Faculty of Engineering, which is called Studio de Création. So it's really like a big fab lab. And it has been open since 2019. And so they have, 3D printing, they have electrical engineering, like places that they have découpage laser. How is that translates? I'm not sure. Laser cutting.
Yep. Yep.
They can work with wood, plastic, whatever. They have all tools possible so that they can make stuff. They even have like a sewing machine, so they have really like everything, and big spaces where you can meet and make stuff. So it's really like a nice add-on to the university here.
Yeah. So their mandate was to design this from scratch, build it, troubleshoot, get it working, and you can see on the video it is really quite agile. So they were rocking it back and forth. It's very similar to some of the videos you would see from the Boston Dynamics. They even take a broom here and try and knock it over, and that's a super cool project. Did they make this robot fully autonomous? Is there sensors also mounted on it?
That's a good question, actually. This is one project where this year usually we have like a public presentation of all the robots that have been built throughout the winter, the winter term. This year, instead of having this because of the pandemic, the teacher asked for the students to make a video. So we have like all the information I had, unfortunately, was what I had with the videos, and then some students that I've chatted with, but I'm not sure about this one. However, like all the projects had to be open source. So this is like one of the rules for the fourth term project. And well, as you can see, like they've built this robot from scratch, from like themselves, but they can rely on something open source that was already on the market. So they can just start from, an open source project saying, oh, we'll start from this project, we'll add that kind of feature. We'll try to do something different because we want to experience like this specific thing, or, add a feature to the robot or whatever. Or they can start from their own idea from scratch, saying we'll develop something, but we'll put it afterwards on the open source. So
okay, so the projects afterwards, they are open source?
Yep.
Okay. Oh, very cool. Very cool.
And it's nice because some projects, like this is the third time that we've done this term. So sometimes the students decide to build on the project that was done by the students the year before, saying, oh, this was a cool project. We've seen it in the public presentation the year before. So we'll start from there and make something a bit better, and then improve one robot from 1 year to another.
Okay. And I see, so right now we're looking at the simulation of their robot, the Quadris robot, and they're using Gazebo. So this looks to me like it's the ROS open source
Yep.
robot.
Yeah.
Okay, is that is this a little shout out to you, David? Is this your influence?
No, not really, but I recognize the environment. Yeah.
Yeah.
And to be honest, it's quite impressive. You always get that, couple of groups of students that get to impress you. Like you go like, how did they end up, doing so great? And I mean, it's always impressive. Never underestimate a group of students. When they get going on something and then it's something they engage in. I mean, it can give really impressive results. And as Audrey mentioned, I could definitely see a group next year building on this robot, adding on, I don't know, something on top, a camera and a screen, and that makes you a telepresence equipment. So I mean, you could go different levels with that. But I'm always impressed when I look at what they can achieve. It's always really cool.
Absolutely. And I think these style of robots are really important because the limitations of where they can go is much lower. They can go upstairs, they can go across rocks, so it opens up big time the possibility of what you can use robots for. So that's really promising style of robot in my opinion, and I'm expecting to see applications that we had never thought of possible before. And we go, wait, how did they come up with that? And it's going to really open up the industry.
Sure.
Okay, so next one is called Scarus. So it's a robot, a five-axis robot. Hold on, I'm just gonna. Audrey, maybe you want to describe it?
Yeah. Actually, it's a robot that takes little nuts, and they will just like classify it. So yeah, you have, well, actually, it looks like something you could have in the industry, saying, is that a good part? Yes or no. So there's like a little camera that will inspect the part, and that will decide if it's wrong or good or wrong, and then it will classify it. And so if you go a bit further, I think in the video, well, they just like say, well, we have printed all the parts and everything, but it really takes like there's like it takes the shape, I don't know if it's the good term, of a Scara robot. And so they have a little magnet that will pick up the part and decide if it's good or bad after the camera inspection. And then like the camera is, it's like the nut really falls into a little slope, and then the camera takes an image, and afterward the nut comes on a kind of a black surface, and then the Scara robot comes into comes and picks the part and decides if it's right or wrong.
It's pretty cool. It's two motors, and you get 4 links. And I mean, it's a kind of dual arm Scara robot, and I mean that's a cool exercise to do for as students to probably do the models and do the algorithms for that. So that's really interesting. It's really different from what we just saw before, which was more of a dog robot, really. So that's cool. The diversity you get to see as well.
Yeah, and I think just to build one kind of robot that already exists on the market, it makes you understand what is the how it works, and what is the strength of that kind of robot, and what are the things that could be improved on that kind of robot. So since they build it from scratch with the motors and 3D printing and stuff, it's like, oh, okay, this is good. Or when they'll be using maybe robots that are already built later on when in the workplace, they can they have something to relate to.
Yeah, and one of my predictions is, and we see it happening in China. So China outinvests the rest of the world in robotics, and the number of startups. There were some reports that I saw, but the number of startups and the number of new OEM brand robots coming out is really phenomenal. So there's a lot of still market space, and one of the promises is that this technology will become more affordable, and it's through innovation like this. And as these open source platforms become more robust and easier to use, I think there's a great opportunity for companies to do more purpose-built robots that are still reliable, they're still based on solid technology, but that unlock the potential of solving some of the more unique problems. So that's one of my predictions. As you know, the collaborative robots, I lost my word there for a second. As collaborative robots become so simple to use, a lot of the brain power will be shifting to more purpose-built robots and solving problems that are thought not possible because of some of the limitations with the 6-axis standard robot. And for sure, the tools we have now, you're not limited to that anymore. So seeing some of these students combining machine vision, the motion, they're setting themselves up to do some really interesting things in the future. Now, the last one is one of my favorites. So it's called Mixus. So you definitely get the university vibe here.
Yeah, to put it in context, I think every year there's that kind of project related to alcohol and partying. So how can we make a robot? We had a robot even in the past years where it was it was really like in using an industrial robot, like a real one, industrial robot. It was still the robot was serving pizza, well, fake pizza, and getting money for from the customer, and then the customer could choose its menu from I want to have a pizza and a beer. So this one is really about making drinks automatically.
So maybe break it down and describe it to us. Like, what are some of the components that go into this?
Yeah, well, actually, I think in all the videos you always see something like with 3D printing, because really
that's a big one.
Always that's something common for all projects, I think, since it's so easy to use. So they have built kind of like a small bar where they can put I think it's 6 different bottles of vodka or whatever on top of it, and they have like a little distributor. So the machine. You use an interface to select the drink you want to have. You put in a glass into the little machine, which is all closed. So the machine will take the glass and then will take the glass from one little station to another, adding either juice or alcohol in it, depending on what the user has ordered. And then when you see the little glass coming to a station, it will just like go the little. There's like a little platform that will go up so that it touches the bottle and the liquid drops into the glass. And so it's kind of like, how to automate a bartender, really. And then the glass comes out and there you have your drink.
So how did the drinks taste? Were they mixed well?
That's a good question. That's the thing with the pandemic. You don't really try out the robots at the end. But to be honest, in the first projects, though, I always at the end of one term, I always come with my little kids to test out the robots, and this is really fun to do because my kids have I think in the first one we've done this term, my smallest one was 3 years old, maybe, or 4. And he was just using the robot not as the students would have planned it a few years. So my kids are really experts in making the robots go wrong. And so the students are just like, how did this go wrong? Well, at one time my little Gabrielle was just like clicking nonstop on the little mouse. Asking all kinds of commands to the robot. He's like, it's not working. And and then it just sends out all different kinds of commands to the robot, and the robot was just confused. So this is quite a nice lesson, I think, for the students, saying, put it into the hands of real users, not users that will use it as it was planned, but different kinds of users. And when you put it into the hands of a 3 or 4-year-old kid, you really get, interesting interactions.
Oh, absolutely. Everybody's expecting technology now to work that easily, and we have the iPad to thank for that. Where my kids are better than me at using some of that stuff, but everybody is exposed to it. So when you go in and you pitch your tech, it's got to work just as well and just as simply as some of these tablets do.
Yep. And actually, it's part of the process, like especially in that term, it's part of the process saying you have to put it into the hands of the user. But let's say especially for that kind of robot, the user was not really the persona was not really like a 4-year-old kid. It was not built for this, but it's still interesting to test it with various users.
Have they thought about the versions of the drinks or
They could have if this one was not done in the pandemic maybe. But no, it was the robot I have in mind was like it was still on the theme of alcohol. It was a beer pong robot, but my kids were they had fun with it because it was throwing a ping pong ball into one of the empty glasses.
Okay, that's a good one. When I was in Ontario working, we did a golfing robot. So you guys took it to the next dimension in the beer pong robot. You got an extra set of dimensions there to figure out.
Yeah, actually, it had a little Kinect device. Just like it used really the Kinect device to see where the glass was. And so what you had to do, you had to just put the glass in different places on the table, and the robot always it was kind of like tracking the glass and then saying, okay, I have to shoot this way. So it was adjusting, saying I have to shoot at that angle and that length. And it was working well when it was not, used by a 4-year-old.
Okay. So if you need a user for that bartender robot, let me know. I built myself a little service robot at home because at nighttime I serve snacks before bedtime. I know it's not good before bed, but we do it anyways. I serve snacks, so it's my robot's going out. But now the summer's coming. I want to adapt it for the pool side, and I need an automated drink server, automatic bartender. So if you guys need a user, keep me in mind. I'll figure out where.
I'll ask the students what they'll be doing with this. I was kind of wondering if it would be used for parties here when the parties will take place again.
Yeah. Well, Audrey, it sounds like you guys have done an awesome job at building out this program. What's in the future? What are some future things you guys are thinking about?
That's a good question, actually. You mentioned, masters in robotics. I'm not sure if we'll go this far because, as David mentioned, even though you have a different label, you're still doing robots because there are a lot of, robotics labs. I think one of the things we want to work on, but it's more, I would say a long-term project, is really recruiting more women into the program. Because to be honest, this is one of the lacks actually at the moment. There are about, I don't know, maybe 5 or 6 girls per year in the program, where we have like a total of 50 students. So it's more like 10%. But I know it can be a lot more, especially because I'm involved in robotics in high schools and primary school, and I see a lot of young girls interested into that field. They just don't follow that path because of various reasons. Sometimes I don't know, I'm not going to be good enough. It's more like for guys because I don't see a lot of women into that field. So we have a few things going on in this. I'm doing conferences with some of my friends, women in engineering, just to try to promote women in the field. So that's one way to go. But I think that there can be a lot more done with high schools and CEGEPs and stuff like that. So I think this will be one of the goals. And one other thing will be probably to, we've talked about students that want to start companies in the field of robotics. So there are a lot of things already at the University of Sherbrooke to, encourage students to coach them into that direction. But there's probably there are a lot of things going on in that field, but I think to kind of consolidate what is going on there in that field would be interesting. And also we've thought a little bit about the capstone projects. So this is one of the things, it was already going on in the, engineering programs here, but with the opportunity of robotics engineering coming in, we now have capstone projects that are including 4 fields, so mechanical, electrical, engineering, software engineering, and robotics engineering. So in the teams, they're all, mixed up together, working on the same project. And we have people from companies suggesting projects, and the students will work onto those projects throughout their year and a half of their capstone project. So I think this is also, it's already going on, but still working on this and improving the way we're doing this and working with the companies as well is one of the goals, not specific to robotics engineering, but it's still part of the program.
Oh, fantastic. Now, with the current conditions, are you guys giving tours of the university for those that might be interested in checking out the campus and what goes on there?
You mean at the moment during the pandemic, or?
Well, hopefully, I guess it's mid-June that things start to relax a little bit. I don't know if, I'm assuming things are going to pick up and we're going to have an awesome summer. So is there an opportunity to visit the campus, assuming that the lockdown goes away, and check out the program for students that might be interested, and parents that want to encourage their students or their kids to get into it?
Yeah, usually it's mixed, like it's how do you call it, porte ouverte? So
open door.
Open doors
Yeah.
for all the university and all the programs, usually in October and in February. The last so the ones for this year were made online, basically. But I know there's also, like, people can call the university and ask for a tour of the campus, and it's I know in the last open doors it was like, well, maybe we'll get that going a bit more in the next few months. So there's always that kind of opportunity. You're being kind of teamed up with a student that will make a tour of the campus. So this is more like a personalized one. But otherwise, it's really well done. Like the open doors in October and February are really well done, and all the info is on the sherbrooke.ca. So anyone that wants to visit, they're welcome to visit us, and they will get to interact as well with current students. Because when we pitch about the program, it's like, okay, it's the best program in the world, but then you can get a bit of a reality check of the students, saying what they like, what they don't like, or whatever about the program. But to be honest, they're quite enthusiastic about the program.
Yeah, it sounds like a great program, and maybe this is a good project, is a robot that will give a tour of the campus if ever we need to. Hopefully we don't go into lockdown again, but you have one?
Yeah, we had one last year that would interact with the people when they come to the Studio de Création that I told you a bit about earlier. So it was welcoming all the students in the the last open doors that we've done physically here at the university.
Okay. Well, fantastic, Audrey. Thank you so much for agreeing to come on the podcast. It's really fantastic hearing what you guys are up to. David, thank you for joining us and sharing some of your experiences and giving a plug to Audrey's program.
Thanks, Mike, and thanks, Audrey. She's really participating in building the future. So thanks a lot. Yeah.
I would add, actually, it's really like a team effort, because there are a lot of teachers here, and people from the industry as well coming in to teach all their knowledge to the students. So it's really like a team effort, quite a big of a team effort to build a program. So, well, thank you for the opportunity. It was really nice seeing you again, both of you.
Very good. With that, thank you very much, and have a great day.
Have a good one.
Cheers.
So this concludes the episode of Robotics for All podcast by AV&R. If you don't want to miss another single episode, don't forget to subscribe to our show in your favorite podcast app. Thank you very much, everyone, and we'll talk again soon.